Hey everyone, welcome back to another episode. Today we're going to talk about how to use Kubernetes to run containers and virtual machines on the same platform. Now we're going to use Single Node OpenShift to do this. And if you remember back to my first video, Single Node OpenShift, or SNO, is just Kubernetes with a small footprint. It was developed by Red Hat for edge cases typically with limited on-site computing resources or constrained environments. So think like 5G towers and telcos and manufacturing facilities and retail stores with not a lot of space for a big data center. So it is tested, certified, and supported by Red Hat, and it's pretty great. So there are a lot of great reasons to use Single Node OpenShift. My first one is basically I like to use Single Node OpenShift a lot for POCs. I spent a lot of time with customers last year demoing the vertical pod autoscaler which is a way to help companies kind of right size their applications for vertically with memory and compute. So that was a great POC. We talked about serverless technologies like Knative and all of that, and Istio and that kind of thing. So great for POCs. It's also a great way to just learn Kubernetes if you want to get into it and understand how Kubernetes works. OpenShift is Kubernetes, so SNO is great for that. And again, it's just great to for a home lab where you need somewhere to test the latest and greatest technologies or explore something that really interests you and or could be of interest to your customers. Quick recap of the requirements: you need a system with 32 gigs of RAM, 8 vCPUs, and 100 gigs of storage. Now that's even if you run it on some type of hypervisor like VMware or Proxmox, or even on bare metal hardware. You're also going to want a free Red Hat account, which you can get by going to console.redhat.com. Console.redhat.com is what we're going to use in the demo here. That's their OpenShift Control Manager or Cluster Manager, or OCM. You need the ability to create DNS records. So if you don't own a domain, please go get one. You're going to need one. And we're also going to use it with Let's Encrypt, which I'll walk you through so you can have a globally recognized certificate on your Single Node OpenShift instance. You also need the ability to open up some router ports. And then finally, I'm someone who likes to use the GUI sometimes, but I also like to use the command line. So you're going to want command line access as well. As always, let's start talking about the problem and define the problem and the objectives. And basically, there are two emerging trends here. There is a need for a better modernization strategy for VMs and VM-based workloads. We know that the future is declarative. Everything is infrastructure as code. And yes, you can do infrastructure as code today with VMs. But, there's Kubernetes and containers, and then there's the VM world. So that results in a lot of split IQ, what I like to call it. And, when you have a lot of split IQ, that can get complicated, and complication adds expense. So a solution would be to run both containers and VMs on a single platform, which you can do. Using kubevirt, sound familiar? Libvirt, anyone? Yeah, libvirt for KVM, super popular. Try it, been around for a long time. Rock solid. And kubevirt can bridge the gap for applications that are not easy to containerize. You can also use the Kubernetes API through kubevirt for virtual machine management. And the bottom line is this gives us a unified platform for container teams and for those existing VMware teams. And I can't really find any weaknesses with virtualization on Kubernetes. kubevirt even supports things like PCI pass-through. So if you have a really cool NVIDIA GPU and you want to test out an AI-based workload, you can expose that through kubevirt. Also, my head's blocking this. Last word here, you can expose USB devices as well. So you can do snapshots, all that stuff. There's really no drawback to running VMs on kubevirt. So I have some recommendations based on my experience for OpenShift virtualization. Number one, you want bare metal hardware because you could technically do nested virtualization, but the performance isn't great. So I would recommend some kind of, again, single node bare metal, because that's how we're going to do the install, with at least 48 gigs of RAM, 10 vCPUs, and 2 hard drives. We want 2 hard drives because the operating system is going to go on one, and then we're going to use a second drive for persistent storage. Again, you're going to want a free Red Hat account to access console.redhat.com, because that's how we're going to create our ISO for our install, our customized ISO, I should say. You need the ability to create record creation. And while Let's Encrypt is optional, personally, I don't know about you, I hate looking at ugly certs. Let's Encrypt is free, it's fast, and it's fantastic. So I'm going to walk you through how to add a globally recognized certificate to the cluster. And then finally, as I mentioned before, you need the ability to open up ports on a router so that you can access maybe containerized applications running on port 443 and access the OpenShift API running on port 6443. So with that, let's get started. I will post the instructions on GitHub, and I'll see you over there. Okay, over at console.redhat.com, I'm going to log in with my free Red Hat account. And I need to navigate to the OpenShift section, where I will find a list of any clusters that I already have. Now, I already have an instance of Single Node OpenShift, but I'm going to archive that for now, because I'm going to create a new one. So I will click on Create Cluster. Then I will click on Data Center, Create Cluster. I'll fill in the details here. I'm just going to call it Snow for Single Node OpenShift. My base domain is OpenShiftHelp.com. That's a domain I own. Now I'm going to check the box to install Single Node OpenShift. And of course, it lets me know that it's not HA. Then I get a list of operators that I can install with the installer. We're going to use the logical volume manager, but I'm not going to check the box here under the operator section, and we'll talk about that later. So I'll click on Next. Now I need to add a host. We'll click on that. And then I have 3 different types of images that I can create. A full image if I need network customizations, a minimal image, and then of course I can use the old-fashioned iPixie. But I'm just going to use the minimal image for now. So I need to copy my public key into the clipboard. So I just will type this command, I will cat that, and then pipe this out into a command on my Mac called pbcopy. I switch back to the hybrid cloud console, click on Generate Discovery ISO, and I have 2 options: to download the ISO directly or use the wget command. I'm going to use the wget command. I will switch to my desktop here, and then just paste, and then the image will download pretty quickly, and that's it. Step 1 completed. Okay, so now I need some kind of program to flash that ISO. In this case, I'm going to use Balena Etcher to flash my USB drive for the install. Okay, once you've booted your system off that USB, we'll go back into the console here and follow the next steps. So I need to give a host name to my instance. In this case, I'm just going to call it snow-dev. And if you expand the options here, you'll see the NTP server, everything that's ready to go. It will tell you what kind of hardware you're running. It will have the IP address of your system. You're going to want to use DHCP reservations there. And then for the storage option here, you're basically going to flash both drives. The installer will format both if you have it checked, so everything will be wiped out here as it notes, letting you know it's all going to be wiped. So make sure you get any data off there, because both drives are going to be kaput. So then we can scroll through our networking options here. We have the machine network. All that looks pretty good. And then we're going to review our options. Just one more time, the host inventory, the networking, all that stuff looks good. So let's go ahead and click on Install Cluster, and we will start the process. Okay, so the install process should go pretty quickly, but that depends on your configuration. Mine took about 25 minutes here, so not too bad. And if you click on that link that it provides you, you'll get that ugly cert error. We're going to fix that first. Okay, so let's open up a private window in Brave so that we can bypass that certificate warning. You'll still see at the top it still says not secure, but at least we in private browser mode we can bypass that and log into the cluster. Okay, so here is our OpenShift console. You'll see there's a warning here about 2 pods. Those are just installer pods that are left over. They don't clean up automatically for some reason, or maybe they do. I don't know. I just delete them. No big deal. We're going to want to copy the login command here, and this is where we're going to need the CLI access. I've already installed the OpenShift CLI tools, which includes both the OC command and the kubectl command here. So I'm going to paste that login with the API token, and it looks like I'm in. I'm now in the cluster. And you can see the roles are for control plane, master, and worker. So we're all good there, ready to go. We can access the cluster through the CLI. So now let's go get a new certificate from Let's Encrypt using certbot. And yep, I'm just going to renew and replace my existing one for my domain. Great. Excellent. So we've got our cert. That is good. That expires in 90 days. Now we need to run some OpenShift specific commands here. So the first thing we're going to do is we're going to create a config map based on that Let's Encrypt certificate. All right, that succeeded. Now we need to patch the proxy cluster. That succeeded. All right, next we're going to need to create a secret based on that private key in the OpenShift ingress. So let's run that command. Succeeded. Excellent. And then lastly, we just need to patch the ingress to use that new globally recognized Let's Encrypt certificate. All right, that succeeded as well. So we can clear out those commands. And then if we switch back over to the console, you're going to notice that some things are starting to become unavailable. That's because the cluster is updating itself to use that certificate. It takes about 5 minutes, so don't worry about it. Just hang in there. And if we switch back to the console, look at that. We no longer get that ugly certificate error. We now have a globally recognized certificate with which we can use to access the cluster. So we'll log back in. Things are still updating. They might be a tiny bit slow at first. Don't worry. Again, the cluster is just kind of updating itself here. You can see a couple of operators are updating here. The kube controller manager and the scheduler. Yeah, no big deal. Okay, yeah, we're ready to go here. So let's go over to the operator hub where we're going to install the local volume manager operator. And this is going to provide local storage on that other drive that we have installed in our system here. So again, things might be a tad bit slow as the cluster updates with that new certificate. Just be patient. Okay, so we just click on install, and we could change channels if we wanted to, but we're going to stick with the latest and greatest. It's going to create a namespace here called OpenShift Storage. It's letting us know that we need to install an API afterwards here, but let's go ahead and just click on install. No need to customize. The defaults are fine. Okay, so now let's create that custom resource definition here. And I'm going to use the YAML view here just because I want you to see some of the options. If I go back to the command line here and I just SSH into my single node instance, let's run the lsblk command here. I want you to see the drives that I have installed on the system. So there's the one drive there that's the NVMe drive. 1N1, that's what we're going to use for the local storage. And then on the other drive, we have the CoreOS operating system that the assisted installer laid down. So I just kind of wanted you to see that, and that's where we're going to, or that's the drive we're going to use for our storage. So if I go to, the YAML view here, and I customize that, and I add dev nvme1 v1, and then I paste that back, and I click on create, this is going to create the custom resource definition for use with my local storage. So we'll give that a minute to kind of go through. Okay, and then if we browse down to storage and we look at storage classes, you'll see here, there it is, LVMS, LVM storage. Excellent. You'll notice, though, over on the right side here, that it is not the default storage class, so we'll still need to run an additional command there to make sure that anything, any other operators or functionality that we add uses the LVMS storage as a default. So, and yep, if we browse back here, it's all ready to go. Check light's green. So let's switch to the command line here. And again, if I type in oc get sc for a storage class, you'll notice that there it is. There's my one and only storage class there. It is not the default. If it was the default, it would say that next to that, next to the name in parentheses here. So let's patch the storage class so that it is the default storage class. Very simple command here. Paste that in. Now if we type in oc get storage class, there we go. Now default shows up there in parentheses. So that's great. So that's ready to go. Okay, so next we want to create a persistent volume plane for the OpenShift registry. So we'll do that. So let's paste that command. And then we need to patch the registry so that it uses the storage. Okay, so let's switch back to the console here, and you can see under persistent volume claims that I have a PVC for the OpenShift container registry. I'm going to do something similar here for the OpenShift cluster monitoring. I have a custom YAML example that I'll include here in the instructions. So to apply that, I'm going to say oc apply-f cluster monitoring config.yaml. Okay, we're good there. And if I switch back to the console, you'll see I have a new PVC for the OpenShift monitoring stack. We're all good there. Last thing I want to do is I want to add a non-privileged user. So I'm going to use the htpassword function to add a non-privileged user to OpenShift. And I'll upload that. Just click on add. That might take a minute or two to install. And then you can simply log out up there in the top right hand corner and switch users to a non-privileged user if you like. Okay, lastly, let's add that virtualization piece. So I went ahead and installed the OpenShift virtualization operator. Pretty dead simple, just install all the basics. And you do that by going to the operator hub and just searching for the OpenShift virtualization operator. Grab that. Okay, so it's installed. Now we need to create the hyperconverged CRD. Okay, so click on create that. And again, you can just click through the defaults. You don't really have to do anything special here. This should be fine just to get started. So just click on create. And this will take a few minutes to provision inside your Single Node OpenShift instance. And you'll notice that it's spinning up a bunch of pods here. It's going to modify the console along the left-hand side. So again, just give it a few minutes. And the hyperconverged infrastructure should install. And you'll get a refresh warning to refresh the console. Okay, now you'll notice along the left-hand side there, we've got an added option, virtualization, and again, you'll see lots of pods are creating right now. They're adding some base images here in the OpenShift Virtualization OS images namespace, like RHEL, 7, CentOS, things like that. The operator will install a bunch of different OpenShift virtualization options to get you started. So again, that'll take a few minutes. I'd say give it about 5 to 10 depending on the speed of your system here. If you navigate to the left-hand side there, click on virtualization, and then virtual machines. You can create a virtual machine here. You want to create a different namespace. I'm just going to browse here, but just to show you the options, you get this really nice menu here. Now, OpenShift Virtualization supports whatever Red Hat supports, whatever Microsoft supports. So if it's a supported OS, it's supported by Red Hat here. You have different workload types. You can kind of filter. You can go to instant types, similar to something like you would see in one of the hyperscalers here with like a series size, kind of like different t-shirts. Very, very flexible options. Again, very cloud-like experience applied to virtual machines. So let's log out here. I'm going to log into that non-privileged user. I'll click on login. Might take a minute here, or a few seconds just for the console to kind of come up. And we'll let that let the console come up. All right, so let's go ahead and create a project here. And we'll just call it, VM container, give it a display name. VM container, that doesn't really matter. It's whatever you want to call it, or VM and container, that's fine, for a demo. Okay, so just like we would do with a container here, we're going to click on the add page, and we're going to navigate to virtual machines, and look at that. We have a nice menu here with some t-shirt sizes. Ready to go right out of the box. I can customize the CPU and the memory. Let's say here we want 2 CPUs and 4 gigs of RAM for this VM. That we need RHEL 8 for some particular reason. Maybe a version of MariaDB that only runs on RHEL 8. Okay, so we'll let that provision, and then we're going to add a container. And everyone likes Pacman here, so yeah, we'll navigate to my Pacman example here. It's a Node app, and OpenShift fills in the rest here. It's going to create a secure route. So then we'll click on Create. Okay, there we go. So the container is building there. It's creating, and then our VM should be ready. Typically, the VMs spin up very quickly. We're talking like sub 10 seconds here. You can kind of browse here. It kind of tells you what's happening. Click on the console here. It will automatically provision a username and password if you don't specify one, but you can. Let me log out here. Log back in. Display token. And no, I'm sorry. I want to actually grab the login here for this namespace. And I'm going to switch projects here to the VM container project. If I type in oc-get pods, you'll see I've got 2 pods here, one for my containerized app and one for the VM itself. Because believe it or not, the VM actually runs in a container. So if you download the virtctl tool, and I'll include that in instructions here, and I grab the name of the VM, which was auto-generated here, I can use a VNC tool to log or use a remote console into my VM. So let's see here. The login here is just cloud user, and then I'll type in that password. Whoops, password went away. Let me just navigate back to the console here, grab that password. Okay, we'll just type that in just to prove that I'm not lying. And okay, almost there. And look at that. I am logged in. I can type in PS top. Let me cat the Etsy Red Hat release. There you go. You can see it's running RHEL 8.9. And that's it. That's it. So that's a great way for you to run containers and VMs side by side. I hope this was helpful to you. Please leave any comments down below. I appreciate you watching, and see you in the next one.